All right, I'm ready.
All right, welcome everyone. We are here with IoT World. This is a live session. It's being recorded. So I just want to let everyone know that if for some reason you don't want to be recorded, now's the time to drop off. But please let me introduce Johannes Strag, and he will be our moderator for this session. Johannes, the floor is yours.
Thank you, Greg, and welcome to our great session. Cybersecurity architecture and governance for IIoT implementations, so focus on the industrial field. We have wonderful speakers for you today. I want to say good evening for me because it's already past 6 p.m., but it could be good morning for you or good afternoon, depends on where you are. That's the wonderful thing about our connected world. For us as speakers today, there's another benefit. We didn't have to travel, we just meet virtually. When we look at connectivity, we know that there is one thing very important happening at the moment. We have 20 times more connectivity than we had 10 years ago, and we will have at least 50 times more connectivity in the coming 10 years. Now, setting up cybersecurity architecture and governance for everything that we are going to do, and especially in the industrial area, that is an important topic. And that is what we are going to look at today. And we have 3 wonderful speakers. I'm very proud that I'm allowed to moderate this panel and join the discussion. We have Joseph Sanders from Cybersecurity, which by the way also sponsors this session. We have Michael Lester from Emerson, a giant in the industry. And we have Srinivas Kumar. I hope that I finally pronounced your name right, my friend. I've practiced the whole day, from Mokona. And it's going to be a wonderful, wonderful discussion. Now, the first thing that we are going to do for you, so you know all our speakers, that if every one of us will have a 1-minute pitch. My name is Johannes Drogaard, but most people call me JD because that's much easier to pronounce. So stick with JD. I'm fine with that. And I would like to ask Joseph to do his first minute pitch and let us all know who he is and what he does.
Thank you very much. It's nice to be here with all of you in the audience today. My name is Joe Saunders. I'm the founder and CEO of Cybersecurity. We are a cybersecurity company that is working on protecting software across the IIoT infrastructure and architecture. So, at RunSafe, we assume that bad actors will find a way to breach networks, insiders will get into organizations, and supply chains will be compromised. So our mission is to create resilient software, assuming those events happen. And I very much look forward to the discussion with my panelists today and in questions from the audience and all of you today. Thank you.
Thanks, Joe. I love this concept of assuming that there will be an exposure and assuming that there will be an issue and start from there. I'm really supporting that thought. Michael, could you give your 1-minute pitch, please?
Sure. Thanks, Johannes. Thanks, everyone. This is a great panel to be on. I appreciate being here. Welcome to everybody in the audience as well. Michael Lester, I'm the Director of Cybersecurity Strategy, Governance, and Architecture for Emerson on the product side. Emerson is a global technology and engineering manufacturing company providing commercial solutions and industrial solutions. We have 2 business arms. One is commercial and residential, and the other one is automation solutions. I work in the automation solutions side, where we deliver industrial solutions from the sensors all the way up through cloud. IIoT is specifically a focus for me as well, building secure development devices, building security in, maturing the capabilities that we have within these solutions, connectivity and cloud solutions as well.
Thank you, Mike. That is a very broad area that you cover with Emerson, and it's good to hear from you, a person from all the aspects of the field, how that is progressing. I'm happy that you are on board with us today. Srinivas, could you please pitch us who you are and what you're doing and why it is so good that you are with us today? We hear you much better when you are unmuted, my friend.
Okay, there you go. I'm the Chief Technology and Product Officer at Mukana. Our vision and goal here is to provide cyber protection in this emerging era of industrial IoT and non-industrial IoT, as we see a convergence of OT and IT technologies. And so our focus is on hardening brownfield and greenfield devices in a way that we can harvest device intelligence and provide it into the artificial intelligence and machine learning engines and orchestration engines. We drive our solutions through the standards that are emerging in the industry and try to empower the field operators and device vendors with this passage to this new era of digital transformation.
Thank you, Srinivas. I'm very happy that you used my favorite magic words, greenfield and brownfield, because that is the reality when we look at industrial environments, right? And I'm very curious about what you will share with us today. Thank you all for this great introduction. We're on our way now with our session, and I want to start with Joseph Saunders from Run Safe Security for the first contributions. Joe, you have the floor.
Thank you again, Johannes. And on my first slide, I think it's appropriate for all of us as we talk through, and we're absolutely curious what you all in the audience may think of this. But there are a couple interesting statistics out there related to this topic of architecture and governance. And what better topic, as Srinivas mentioned, around AI and analytics, to consider then some of the implications around data that is captured in these devices and sent for processing. And so one thing that we have seen is that over 75% of enterprise generated data in the industrial settings will be created and processed at the edge, and that will be by 2025. So a very interesting statistic as we consider our governance and our architectures around IIoT in general. So that's one statistic. A second statistic is that for those vendors who provide IIoT gateways, they will offer 5G communications in a product, at least 80% of them by 2023, or have plans to do so. And that's an interesting statistic given the nature and transformation of infrastructure and communications that 5G enables going forward for the industrial environments that we all are familiar with, in our own considerations. And so, as a panel and as a group, and certainly from my IoT world's perspective, we do have a couple poll questions that are related to these two topics, and we'll be curious to see how your own plans align with these two statistics. Maybe they vary greatly, or maybe they are consistent in your view or understanding as you consider your own plans going forward. So we do have polling questions to ask about how data is captured, and if 5G is on your radar today for your considerations going forward. So in thinking about the architecture on the next slide, what we have thought about here is, sorry, I just can't see something. Okay. What we've thought about is, kind of two things. We want to give you a conceptual framework for how IoT in general is done, and use this as a means to show where some governance questions are. So I'm going to provide, an overview of very conceptual understanding of IoT environments, and then dig a little deeper into IIoT specifically. But on the left-hand side, we have all the things that connect to our platforms and our systems. So these are the devices that are out in the field that are collecting data and transmitting back. And then we have one of two options, sort of the edge itself for processing and analyzing. And if you recall in the previous statistic or slide, the statistic said that a lot of the processing will be done at the edge. And so naturally securing that's an issue, naturally thinking about local decisions and what kind of governance you have for making decisions at the edge is an important consideration in this kind of environment. And then we have the IoT core, which is really the cloud environment in a more centralized location for aggregating information and aggregating decisions. So you have information on the edge where decisions can be made, and then you have the core where cloud hosting environments are. And then attached to that core in the background, of course, is the enterprise, the operators, the solution providers who can ultimately make decisions based on all that aggregated information. So there's enterprise level decisions, there's aggregated data that comes together for decision making, there's decisions that can be made in local environments, and then there's the collection that occurs with all the things that are out there. And so we'll be curious to see as we go forward in our discussion, what some of the implications are in this very conceptual framework. But if we go to the next slide, we can talk about, IIoT in a little bit more detail. So again, extending the concept of a conceptual architecture, you can see here we spelled out what some of those devices are out in the field, and they can be industrial assets that are involved in factories. They can be in-vehicle electronic equipment. They can be cameras. And oftentimes in those industrial settings, those assets are communicating with controllers or PLCs, and ultimately, based on a variety of protocols and communications, the information collected by these devices out in the field, if you will, into industrial IoT gateways that help then send that data into an aggregated repository or processing in the cloud environment. And so we've taken just a little more specificity around the IIoT environment in general, from the IoT, diagram that I had on the previous model. So in effect, there are all sorts of additional considerations we can think about when we look at this diagram. Those include security considerations in addition to the decision making I was talking on the previous slide, as well as acquisition kinds of questions around your industrial IoT gateway and what that performs and where that resides. So there's many questions that come up based on the architecture that you may have, and if you consider 5G implications, decision making and data, and then security, you can see that the wealth of considerations from not just an architectural perspective, but from a governance perspective, become very critical decisions for an enterprise to make. Next slide, please. So I mentioned in my opening remarks that RunSafe assumes that organizations will have compromises. There will be breaches to your networks. There will be insiders who get inside organizations to try to do some damage. And then supply chains always present a risk, especially as we consider revamping our infrastructure with 5G and consider acquisition of products in general that process our information, not to mention cloud-related implications. From a RunSafe perspective, we recognize that these compromises can happen, and our aim is to immunize the software directly to eliminate the ability for the attacker to compromise those systems, those devices, those edge devices. We also recognize that in some of these settings, that infrastructure is hard to gain access to, and patching may not always be available. So providing proactive defense on devices and in cloud workloads becomes very paramount, as well as in our OT and IT networks in general across our open source software. So I believe then, another consideration overall is to consider your patching process, your maintenance process, and how you embrace what looks to be untrusted networks that often carry open source software. And so from RunSafe's perspective, we try to help you create resilient systems, resilient devices, given the potential threats that exist in the overall architecture. So that concludes my prepared remarks, Johannes.
Well, thank you, Joe. That was a very good part. I picked up a couple of very important items here. One of the things that I really work with is what you mentioned, restriction on access, that you will not always have access to everything in that network, and that you have concepts for that. That is a very important topic. I also have a question for you, Joe. With the current environment in IoT, where do you see the biggest risk?
So naturally, there's many points of risk that is out there. One in particular I consider to be paramount is within the IIoT gateway, as that is really an access point that all the other devices are feeding. However, you can also consider that the edge devices and all the things that are out there are vulnerable to being compromised as well. So it really ultimately is probably unique to every organization as they consider their risk management framework. And so where is the critical data? What are the assets that are most fundamental to mission critical decisions? And if you think about the likelihood of an attack and the severity of an attack at any of those endpoints or in the cloud environment, all of those represent areas that people need to consider. And in each organization, their level of maturity may vary in each of those areas. So it is very much an enterprise decision. However, I do recognize that with all the connectivity, both the devices and the IIoT gateway become vulnerable in many ways.
Thank you, Joe. I want to add some statistics to this, especially because of the combination brownfield and greenfield. 82% of the infrastructure and manufacturing capacity where we are deploying our wonderful edge and IIoT devices, 82% of that is not built in this century. So that means there's a lot of brownfield equipment which is gradually connected, and that will be a core job for the IoT gateways. But we need to always be very aware and make smart decisions, as you mentioned, real enterprise-driven decisions about the risks and what mitigations and countermeasures we implement. That's sometimes disturbing statistics, but it is part of life. With the shift to edge processing, Joe, how do you see security and mitigation changing?
So I think with edge processing, the question becomes, how often can you provide updates to those systems? And so naturally, having security built in is a critical function. And so the distributed nature of decisions means that there is not just governance questions, but security questions there. So I do think a strong understanding of what the security is on the edge and on those devices is very critical going forward, and obviously an area of opportunity. And so to your point on the brownfield devices, having security on older systems and on devices that may be legacy oriented even, finding ways to reduce capital expense and still provide security is a core question as well. And I'm actually kind of curious around edge processing, if I could ask one of my colleagues here, Michael, just how edge processing factors into your roadmap from a product perspective and the like, and would greatly appreciate your perspective as well.
Thanks, Joe. That's I can't say I'd say that I agree with a lot of everything that you said here. From an edge processing perspective, from a roadmap, we see that as beneficial, and certainly things are moving to the edge or moving wherever you define the edge. The edge might be down at the control level or the safety level, or even at the between the enterprise and the factory level, depending on what you're looking at from an architecture perspective. So where you define that edge is also important in this as well, because we don't like to move control and safety too far away from where they're actually, managing and monitoring processes and keeping things safe and operational. But it certainly is a factor, and we do look at this on, where it makes sense. What can we process on the edge? And I would say I would actually, pull on that thread a little bit more and go back to which data is important? Where do you need to support the decisions? And also, how do you move that data to that workload to do the processing, and what comes out of there, and who gets access to that? So I think it's all kind of strung together, but certainly, edge computing it plays into the roadmaps.
Very good. Well, thank you, Johannes. That concludes, I think, part of my session.
Thank you, Joe, and thank you for the great conversation and contribution as well, Michael. Very interesting. I think we should have the polling results by now, but I cannot see them yet. Can you pop them up or share them with us, Greg? Okay, there we have them. Interesting results, Joe. The first question, is data captured at the edge already growing in your environment? 64% answered yes. 2% answered no. Not sure, 20%, and not applicable, 13%, which is logic, right? So if we focus on the yes, no, and not sure, there is a very clear majority with 64% saying that edge data capturing is already growing. And the second question, I will share that with you immediately, Joe. I know you're very keen on this. Is 5G on your company's radar today? 47% answered yes, which is fantastic. 22% answered no. And not sure and not applicable is 13 and 18%. But again, if we take out the not applicable, we see a significant majority answering with yes. And knowing that 5G will significantly increase our option for connectivity, I think that's a fantastic outcome, Joe.
Yeah, I would agree. And to me, those statistics make sense. The 75% number that I offered up front, is very consistent, I think, especially if you say you take out the non-applicable in that first question. So to me, the data reflects from our audience that they're well in tune with, what the implications are for data being processed at the edge. And certainly 5G, going forward is going to present a significant, impact to our industry in general.
Definitely, I agree with that. 5G will enable us to pull in data from everywhere and transfer that into information and actionable information, decision-making processes, and most of it in real time. It's a fascinating result. A quick comment for all the viewers that we have. It is possible to already raise some questions and type them in the Q&A. So when you have questions for the speaker, please get them started. I will try to fill them in at the right moment. Joe, thank you for this fantastic session.
Thank you very much.
Mike, I would like to get you started. I can't wait to hear what Emerson has to offer in this area. You have the floor.
Well, thank you, Johannes. Thanks, Joe. And I want to build, what I want to do here for everybody in the audience is kind of build on, the reference architectures that Joe's presented. And as we talk through this, we to kind of take this into another dimension, right? We've got the technology, we've got the reference architectures, we're adding security in. And when I go into the next slide, I want to talk about some of the challenges we have around not just implementations, but understanding and some of the challenges we might have toward governance. If you'll take to the next slide, please. So as we move into, in particular, IIoT, and I think this is one of the drivers, there certainly has been some historical conflict with between the operational technology organizations or functions and the information technology organization and functions, with having diverse missions. And as you can see here, in the operational technology, their goals are different or have been traditionally different than what is, and it will remain that way for unforeseen time to come, than the IT organization and what their goals are, where your operational technology is looking at extracting value with digital transformation and implementing IIoT solutions, as well as looking at performance and availability and uptime Those are key factors. Looking at, as Joe mentioned, not having to patch as often, or having things that are industrial based, the devices that have a much longer lifespan than your typical knowledge worker system or MES system that would be in the enterprise level, where they can sustain or can be life cycled much faster. And that's just part of the nature of what we do on the operational technology side. And on the the information technology side, that's a little bit different view, and that's caused some conflict. But I think what I want to focus on the next slide here is really, even though we have some historical conflicts, it's not about competing goals. It's really about running the business and making sure that we can also leverage. If you'll go to the next slide, please. There's leveraging their collaboration and the complementary strengths that they have, and kind of bringing those together. So we're kind of taking two different domains of expertise and knowledge and moving them together. And sometimes at a rapid pace. Sometimes I see customers who have new organizations that focus specifically on IoT or Industry 4.0 or solutions that enhance their decision-making capabilities more near real time, and putting data into the hands of those decision makers for that decision support in new ways. But we have to, we still have to understand that there are the strengths of the OT department. They know the processes, they know the systems, they know what the risks are to operations and safety. And we need to make sure that those are congealed with the organization's, protection of data and confidentiality, and the other things that focus on from an IT perspective. So protecting the borders, making sure we have the right security, incident response, and the SIMs and the visibility into what's happening when it's happening, so that things can be understood, and really building in, to these solutions where you're solving a problem. Maybe it's, you don't want to send somebody out into a zone in the factory because you have to do explosive gas evacuation prior to anybody going in there to service instruments or to service equipment. So you want to, instead of going out there and manually taking reads, you want to bring that information back into the control room, or put it into a decision maker's hands so they can see trends and make better decisions about when to actually send somebody to one of those potentially unsafe environments. So you want to reduce that and change the work processes around this. And at the same time, you still want to protect the operation. So creating the new data paths and, moving data is going to inherently, if you're not paying attention to, I think to your point, Johannes, you want to make sure that it's done with purpose and it's done with design, that you understand, the separation of controls, safety, and monitoring systems, so that you can successfully implement these things using the complementary strengths of the OT and the IT organizations. Because IT does things at scale. And typically we see OT doing things more in a discrete manner, focused on solving that one problem, right? Or that particular problem that they want to do. So again, optimally, you want to make sure you're using OT and IT strengths. If you go to the next slide, please. To really collaborate, bringing this together and focusing in on how you can solve and support what we call, top quartile performance, moving things in the plant, putting decisions in the right place, and really more effectively managing your operations as a business while putting governance around this. And that's one of the key points that we need to talk about too, is when you bring in the IT and the OT subject matter experts and the functional organizations, you build governance around that to make sure that everybody understands what their role is. You've got new technology, new processes, potentially new people working in new areas. And this is, how we can, how we make sure that we're maintaining the security in an effective way, protecting all of the operations. So kind of moving into the next slide, I'll talk just a little bit to frame up the conversation. And I don't want to put everybody to sleep with all of these numbers. And this is a partial list, but I see 62443 ISA or International Society of Automation standards, really focusing on the OT space and the control system space. But what's really important here is IT focuses on the 27001 series a lot. That's what we see commonly. But they are complementary. And in fact, the 62443 series uses 27001 control sets as normative standards for implementation within the factory and within the control system. So it's they're not vastly different. How you implement them, how you operate, and what you're trying to achieve is well defined in both of those standards, and kind of blending those together is really making sure that we're having the right governance, security programs, and operational programs around new IoT and other solutions. I think those are my prepared remarks, Johannes.
Mike, thank you for that. You're speaking basically from my heart about the collaboration and enhancing each other and finding common solutions. But you also address very clearly and very duly the different priorities, right? If the OT team is much more focused on that process and getting the best details out of that process, the optimal performance, and IT is much more focused on maintaining availability and high uptimes, etc. But when we unite them, as you showed us very clearly, that is when the real music starts. So yeah. I really appreciate your contributions in this field, Mike. I have some questions for you, if you allow me. The first thing that I would like to hear from you is, what approach do you take with architecture, especially around IIoT implementations? What is your approach?
Johannes, I think it's key, and you mentioned it, and I believe Joe did as well, brownfield and greenfield, right? So the approach that I take for implementation is to make sure that we have a very defined business objective, and then work through an assessment process to understand what capabilities exist within the architecture toward that business objective. And where we might have some gaps. So do we need to put new sensors in to get new data to support the business objective? Do we need to implement new systems, or does it already exist and we need to reconfigure what's there within a brownfield? And I think the same applies really to greenfield too. It's you have to start with that business objective, work through an assessment process, understand what your capabilities are in gross detail, right? So it's not a cursory glance. You have to get really down into the understanding the capabilities, protocols, the security zones, the conduits, everything that comes into this. Which data needs to be accessed from who, which systems require that access, and really kind of build it out. I like to bucket these things into the connectivity into three buckets. I think I mentioned this before, bucket into control, safety, and monitoring, and making sure that any conduits or any zones aren't overlapping, or the trust boundaries aren't broken down between those, to make sure that you have that we have intent on securing those particular zones independently and purposeful within the design. I think one other thing I'd like to add to that is too, as we go through this, you really need people that can understand what the risks are, do risk assessments, and do threat modeling, to also include that into the objective of what your end result will be from a security objectives perspective. How you actually implement may be different, and the controls might look similar from a technical perspective, but you also have to bring in the, how does it apply in this particular context?
It's a very good explanation, Mike. Thank you. I like your process of putting it in three separate buckets, with controls, with safety, and with monitoring. And we always need to keep in mind that in the industrial environments, controls and safety have to be completely autonomous and cannot depend on any kind of IT infrastructure, whereas monitoring is, of course, very tightly connected to that IT infrastructure, and keeping those completely separate with their own priorities is the right approach. I really appreciate that, Mike. Thank you. The good thing that we have today is that we all have people with hands-on experience, and Mike is, of course, one of those. So I also want to ask you about some of the challenges that you have faced in this IIoT implementations.
I think one of the biggest challenges that I'm seeing for the interactions that I have now with customers is a lack of understanding about the new connections. And I think I mentioned this a little bit, system interactions, what data exposures you might have, and somewhat of that IIoT, from a security perspective, making sure that it's governed appropriately, right? That your primary focus in the OT realm is availability and integrity versus confidentiality and integrity in that way from an OT perspective, right? So kind of separating those. And I don't want to sound cliche, but because we hear this all the time, it's about people, processes, and technology. And in order to implement these new solutions, some of the challenges are going to be around adoption, right? So if you're changing workflows, if you're changing work patterns or implementing new technology, it needs to be adopted. And the security controls have to be on par with what you're achieving with the digital transformation of the IoT implementation. Otherwise, what you get is people trying to circumvent those controls to make their jobs easier. So as part of this construct and as we think about these things, we have to take that into effect and making sure that we're not overburdening the process with different things. So inherently building cybersecurity into the design with purposeful intent, thinking about the users, how they have to be upskilled, and what their changes are going to be, as well as the technology. If it's a new user interface, if it's a new device, if it's, they also have to understand that. So it's not just about the technology and implementing something, but really about all three of those domains in conjunction with each other.
Excellent, excellent. I fully agree with that, and I also like a lot how you explain how they correlate and how important that relationship is. Thank you, Mike. Are there any questions from our panelists for Mike now that we have his attention?
Well, I would welcome to ask, the question around just remote connectivity for IIoT solutions and how you think about securing those, and what about remote operations and services just in general. So you brought up security as being a core tenet, and I certainly have some thoughts along those lines as well. But I'm curious to see how you think about it, and I'd be happy to give you my thoughts as well.
No, thanks, Joe. I think I'll talk. Maybe bolster your thoughts and Srinivas's as well. I think about this, and I often get asked the question: can we do this remotely? Is it secure? Especially around with everything that's been happening with COVID-19, as an example, forcing everybody remote. Enhancing the capabilities for remote services, remote operations, and not sending people out to site to do the things that they would typically do on site has been, I would say, challenging for our customers and also challenging to a degree for us as well. But we've been completing, factory acceptance testing and commissioning projects remotely, where typically those weren't done; they were done on site. And really, it's really thinking about making sure we have a trusted network, that we can build trust into those connections, and that we have multi-factor authentication capabilities, trusted systems, trusted people, and that we understand and we can monitor all of those connections going in and out. So really taking the core, building that trust within the architecture that you're using for remote services, whether it's using some type of a jump server or landing server in order to get into control system spaces, so that you can still protect those zones and not introduce new risks into those areas effectively. And I would go back, to the earlier question. This is one of those biggest challenges, I think, working and with this, what I've heard say is a hyper-connected world, as we will, and working within that context securely. Going back to, you have to understand it, you have to pull it apart, understand all the pieces of it, and make sure that it can be done to achieve the results that you need for those specific implementations or connectivity models.
I see a lot of nodding heads, Michael. I think that was a very good answer. Thank you very much for that, and thanks for the good question, Joe.
Thank you.
We already have some questions popping up in the Q&A session. but I suggest that we put them at the end so we can all answer them as a group, right? I think that would be interesting for the audience as well to maybe we have some disagreements or not. Let's see. Mike, thank you very much for this very interesting contribution. What I take out of this is a very clear understanding of operational requirements. What I take out of this is, again, the same message we heard from Joe. You cannot assume that everything is secure, so you must assume that there are issues and you build from there. And you keep in mind that operational controls are important, that safety is important, and that monitoring is an add-on on top of that. But the most wonderful part for me is your collaboration model, Mike, because that is the way forward. Thank you very much for this session. I would now really like to introduce Srinivas and ask him for his contribution. One of the things I'm looking forward to a lot, because this is one of the speakers and the companies I have not that much exposure with myself. So this is a learning moment. You have the floor, Srinivas.
Thanks, Johannes. So as we move to the next slide, I want to talk about what is the objective and purpose of this initiative, right? We talked about local decisions, aggregate decisions, and enterprise decisions, and also the need to immunize software at birth, as Joe mentioned. What I'm coming from is about informed decisions, because things need informed decisions, because at the end of the day, it's driven by outcomes. So what are the objectives in the OT IT world, which really is a separation of the CISO role with a risk officer role, right? So different mindsets, like Mike mentioned, engineering mindset versus operator mindset. So what I look at here is, what are the habits of a device? Let's say you have a perfect thing. What does that perfect thing look like? And there are 7 habits, stealing this theme from you know who. Persistence of trust. From the time the device is manufactured, it is going to go through a lot of transformations, device transformations. And how do you make sure that that device is still trustworthy? Can I still trust the traffic light that was manufactured 5 years ago? And what is the definition of persisting that trust? Second is, how do I reduce lifetime costs? Because unlike IT, in the OT world, devices are geographically distributed, and sending an operator or technician to the field that's not practical. And so you cannot RMA a traffic light or a parking meter or a jet engine. You have to figure out how you can reduce the lifetime costs, because that's what operators deal with. Then how do you manage the supply chain risk? Because at the end of the day, if the device was perfect, how can you guarantee that there is zero risk? And that means that the insider threat, all the way from the time it was manufactured to changes that happen in the field, whether it's firmware, software, configuration, how do you make sure that nothing lands on the device that cannot be trusted? So as Joe said, if you immunize the software at birth, and only immunized software lands on the device through a supply chain that is trustworthy, then how can malware land on the device? So that's basically the reason why supply chain risk management is critical, especially in this flat world where devices are manufactured in one part of the world, they're shipped and stocked in another part of the world, and they're shipped to a final end user somewhere else in the world. How now things can go wrong. Devices, in spite of all the process, can go into a bad state. How do you recover it? Is there a click you can say, bam, that's I can now trust the device. It's a reset, right? And it's easier said than done. How do you bring it to a trusted state? Then in terms of the data, and we talked so much about how important data is at the edge and in the cloud. How do you protect the data on the device? Is the device a dataless device? Or does it hold data? Does it persist data? If you swipe your credit card on a parking meter, how much does it hold? How do you protect your digital assets? At the end of the day, your software is sitting on devices on a lamppost, the street. Somebody could steal the device, reverse engineer your code, and have your source code available in the black market. So how do you make sure your digital assets are protected and your intellectual property cannot be stolen by purchasing your device and reverse engineering it? And then last but not the least is compliance. So these are the 7 habits. Now, moving on to the next slide, we talk about not all devices are born equal. So you cannot have the same degree of protection on every device. It's just not economical. Protecting a jet engine, you're going to invest millions. Protecting a smart bulb, you're not going to invest millions on that bulb. So it's really the degree of protection depends on how important is it to identify the device. Is it important to know that this bulb is made by a very specific manufacturer? Is it important to know that the ECU on your car comes from a very reliable source? How do you authenticate the device? Because now we are in the world of autonomous devices, devices talking to devices with no broker. So where is the broker of trust? So the devices have to authenticate. One autonomous car made by one manufacturer has to reliably communicate with another autonomous car made by another manufacturer. Why would they trust each other? So the mutual authentication is really born out of identity. Cryptography is a necessary evil now. And as we see with standards emerging, there's going to be more use of cryptography, whether it's device to cloud or device to device. But cryptography cannot be protected unless the keys are protected. So how you protect the keys is very essential, as important as saying you have password-based authentication, which works great if you can protect your password. And so that's what we mean by key protection. And then there's the data protection, because data is the gold, right? Information is what's driving the cloud, and every cloud vendor is thirsty for data. Whoever has more data is the bigger cloud. But how do you make sure that data is protected? Because garbage in, garbage out. And the data has to come from the source, whether it's the IO module, the sensors, the actuators, the controllers, the HMI workstations. Everything is giving data. And can you trust that data? And then the last but not the least is which devices require operational trustworthiness. If it's a device that if it malfunctions can cost lives, then trustworthiness is essential. If it's a device that if it fails means nothing and you can replace it at your own leisure, then operational trustworthiness is not that critical, right? So that's going to guide the why. And moving on to the next slide, there are 3 rings of resilience. At the end of the day, devices have to be resilient. Because when you talk about OT, IT, what is the responsibility of IT and what is the responsibility of OT? When you talk about a device like a parking meter, traffic light, it really comes in no man's land. It's not my problem, it's your problem, and so on. Now, making the device resilient means you have to start with an inner core of trust. You cannot build trust on an untrusted platform. Whether the device is being protected through a gateway to go to the cloud, or the device is going directly to the cloud, the platform has to be trusted. Add power on. We know what we do when some things don't work. We just power cycle and see if the problem goes away. So add power on. Can you make sure that the device comes up in a trusted state? And then from there on, you build on top of it, whether it's communication, whether it's data protection. So self-resilience, self-defending, and the privacy of the data. That's all a function of what's inside. Around that, you build the protection layer. How do you put something, controls, protection controls, that now say, I have a trusted device. I'm going to add in a supply chain protection control. I'm going to add a device integrity control. I'm going to add a monitoring control, and so on. So that's a protection layer. And then once you have a protected device, the last but not the least is trust but verify. How do you measure remotely to make sure that we can prove that this device at this point meets compliance? I can get device intelligence and send that data to an AI ML engine or an orchestration engine. So it can do some digesting of that data. It can do heat maps. It can do predictive analytics and so on. And the outcome of that analytics is going to drive how you respond to a situation on the device. Does the device need a reconfiguration? Does it need a software update? And that's really an outcome. And that outcome comes as a result of trusted data going into an AI ML engine. But there's no M in ML if your device is not secured, right? So let's protect the M. So that's basically what the objective and goals would be. And what are the habits of good devices or good things? What are the degrees of protection? You want to go too far into protecting a device? Is it worth it? And what is essential? And then how do you build resilience all the way from writing the source code, immunizing the source code, making sure that it is sealed, it is transmitted through providers, publishers, resellers, to the device, and the device opens the seal and says, yes, this is good software, I'm going to run it. So that's what I had in my prepared presentation, if you have any questions.
So, let me start by thanking you. I've learned a lot about what you do and what your objectives are, what the priorities are. I think you gave a whole new depth to the definition of zero trust, right? Starting with not trusting and then adding trust when trust is confirmed and trust is proven. But also, and this is something that really makes me think, how do you set priorities for trust, and how much are you willing to invest in that trust? Your example that you mentioned makes that crystal clear, but also what is trust today and what is trust 5 years from now? The traffic light which is installed 5 years from now, very good example. Can we still trust that? Because a simple thing as a traffic light can cause significant damage and even harm people when it's not functioning properly. Great examples, and I love how you make it crystal clear what your message and what your purpose is. I do have questions for you, of course. As an end user of IoT devices, where do I start with such a digital transformation? When I look at brownfield, when I look at greenfield, and especially that very challenging combination.
Right, so that's really the big question when it comes to transformation, which inherently is a change. You obviously begin with the low-hanging fruit, which is greenfield devices. What do I do going forward with new devices as I build them? Because as Mike mentioned, in OT, the longevity of devices is very critical. The devices are manufactured for 20, 30, 40 years of lifetime. And you don't get a second chance at redesigning and recalling millions of devices in a process control plant. So you begin with greenfield devices, Windows devices, Linux devices, because they have the ability to take incremental updates. So you can update in field. You can say, I have devices in the field. What do I do about them? And so that's where Windows and Linux devices, because the incremental nature of their update become the low-hanging fruit. And then you can also do this at manufacturing. So now you cover both your fronts, what's in the field and what is going out into the field. I can now fix things because I have the ability to fix them. And so you also can think about coexistence. You want your new devices to coexist with your brownfield devices. So that's essential. A smarter device needs to learn how to operate with a brownfield device. And that would be the first step. The second is you're going to look at the RTOS devices, the legacy devices, and say, is there hope? There are some brownfield devices that have hope, and there might be some devices beyond hope, and that's the reality. And when you look at these brownfield devices, invariably, you can do that through the device vendor, because a lot of these devices may be monolithic images, and you need the blessing of the device vendor. So you start with the device vendor, whether it's a VxWorks-based system or a FreeRTOS-based system or a QNX-based system, where you work with the device vendor and say, in your next software upgrade cycle, can you provide me some hardening? So that's basically how you do a crawl, walk, run. You start with what you can do, looking forward, what you can do with the in-place patch management systems, so that you're not reinventing the wheel or process, because in OT world, process is sacred. And you're not going to change your process just because a vendor promised you nirvana. So you're going to be critical about that. So that's basically how you start the transformation process. One step at a time, crawl, walk, run.
That makes a lot of sense, Srinivas, and especially the part where you have to accept that not everything is possible in the brownfield, and that you then need to look at what are the options. Can we do that with a vendor? Can we do that on our own? Or do we just need to accept that it will not be the case? But above and before anything else, we need to make sure that we have security in place, right? And that is our main topic today. I have another question for you. As a chief information security officer, so I'm basically above everything. I'm above the OT part, I'm above the IT part. Security is my cup of tea. Where do I start budgeting all these things? What kind of questions do I need to raise to be able to understand what is coming and what resources will be needed?
Well, this is the unfortunate situation that everybody understands the value of security, but not the price of security, right? So from going forward perspective, hardening a device is about amortizing the costs over the life of the device. The longer you want the device to last, the more you have to think about an insurance that you're going to put more money up front so that there's longevity. So when it comes to device hardening, you have to coordinate your updates to that device through the device vendors. You have to work with the line of business application developers as part of their software development process. Like Joe said, if you want to immunize the software, the mindset of developers have to change. So when the next update happens to the line of business applications, those applications might be hardened. They might be using key protections. They might be using better certificate management. They might be better able to handle database attacks, not just code-based attacks, right? So that's a cost, right? Because now you're telling your developers that we're going to raise the bar. Your cycles might get longer. Your 6-month cycle might become a 9-month cycle, and there's a cost to it. There's also the risk management with a cloud-based service or a enterprise-based service that will require a hosting platform because you need 24/7 high availability. You're not going to trust a service that may have a downtime because in production systems, downtime is not acceptable. So you have to work on those cloud-based ecosystems. If you're going to Azure or AWS or Google, you're going to expect 24/7 support, failover, and so on. And then there's the operational aspect, and that is going to probably be the more challenging part because now your operators have to be trained on new concepts. They have to know how to manage these orchestration systems, how to respond to indicators of risks, and how, like a SOC would typically do, they're going to make decisions that would be the interventions and the mitigations on live devices. Right? It's going to be split-second decisions. I have a traffic light outage at a critical intersection, or I have an elevator in a 100-story building that's malfunctioned. You have to make decisions, and that requires training. The first responders and incident response systems will probably be of a different nature because you're not going to do forensics like IT would do. If you are breached, there's going to be the experts coming in to do days, weeks of forensic analysis. Would you really send a team of forensic analysts to do analysis on the traffic light that is down? You want a fix. You really don't want to do a postmortem at that point. So it will change the way SOC operates. It's going to be more responsive. And so those are all costs. The training costs, education, how to deal with these devices, and so on.
So that's definitely not an easy journey, but it's also definitely a very important journey. And I fully agree with you that you also need to focus on what makes sense. The complete post-mortem on a traffic light that doesn't work doesn't make sense, and it takes the resources away to solve the issue. And in other cases, you will want to do the post-mortem because you want to prevent that it happens again and take all your lessons. It's a very, very good point, Srinivas. Thank you very much. We still got questions coming in, so we will get to those as a panel discussion. Do our other guests have questions for Srinivas now that we have his attention for the moment?
Johannes, Mike, I have a question. Srinivas, and I would also like to go back and revisit the investment strategy from the CISO perspective as well. But Srinivas, which industry standards are driving for cybersecurity are driving your focus on the OT for digital transformation?
Yeah, from what we have seen here at Mukana, talking to various verticals, IEC 62443 is a major driver, like you already we discussed earlier in the presentation, and ISO 27000. In addition to that, we are seeing a lot of directives from NIST, whether it's 800-53, there's 80-2, 63-3, and so on, which talks about very important things such as non-real life identity, containerization. And these are all technologies that are coming at us, and we need to prepare for that, especially when we talk about 5G, MEC, edges. Containers are becoming reality, and you heard of Kubernetes and so on. So these initiatives are going to drive standards. There's the important requirement of interoperability across the different device vendors. We want to make sure that in an industrial plant, the various major players, they can interoperate and their devices within standards. There's FCG, there's NERC in the energy industry. There's the FIPS standard in the US in terms of cryptographic compliance. So there are several standards, and they're all basically addressing the same fundamentals of making sure that there's integrity to data, and there are security controls all along the way.
That's a really good point, Srinivas, and I would add to that, and maybe as part of the concept and part of what I think about working in multiple industry verticals like yourselves and others, that you do have these regulatory requirements or standards requirements and all of the standards and you really have to be able to blend all of those together for the right situation. Each one of these IIoT solutions, they're reference architectures as Joe pointed out in the beginning of it, but also you have to realize that most of these are snowflakes and each one of them is different, and you have to apply those standards differently for each one of those. It looks like Joe might want to comment on that.
Well, I'd be happy for Srinivas if you'd like Srinivas to go first. But I just thought your kind of framework for looking at, the controls, the safety, the monitoring, and the unique considerations are in fact important. So I think your guidance gives a clear framework for considering those. But from a technical perspective, to the extent that there is a solution that doesn't require a lot of integration, that doesn't add software to devices, that can have a low impact, I think that is a consideration from the security perspective, at least from a technical architecture wise. But I ultimately think all of these are business decisions based around your view of controls and safety and monitoring.
Yeah, a lot of the decision logic is invariably going to go to the cloud because the devices are resource constrained. And if you want to create a solution that can be on most devices, you want to make the compute less of an issue. So the devices would be really the reporting of data. And once you have the device intelligence, then you have the edge processing and the cloud processing to do an outcomes-driven decision logic. So for processing the data for the purpose of bar charts and pie charts is one thing, but processing the data in order to affect an immediate decision is really what matters, right? If you have a smoke detector that goes off and gives you a signal to a service in the cloud, is the cloud going to say, start the sprinkler? And so there is a split-second decision. So the outcomes can be good or bad based on what the incoming data says.
That's a very important part of this whole conversation, especially when we look at security controls, of course, because there we see still, especially out in the field, the PLC as the main contributor of all those security and safety circuits, in many cases even mandatory. If you look within the European Union, for example, do not suggest to have a safety related circuit based on a remote computing platform, because you will simply not get the license to even start construction, right? And that's also something where we have to move forward and come up with better concepts than what we have today. Regulators need to get involved, because we cannot stick, let's be very honest, PLCs is by now a 50-year-old technology, and we cannot stick with that just because it worked so well in the past century, half of a century. So it's a very important discussion, and it's also something where we need to look to for the future, right?
Yeah, I agree, Johannes. I think if I could interject as well, going back to your investment strategy from a CISO perspective, and there's again, there's people, process, and technology, as Srinivas pointed out. In all of that, you have to consider all of those things. The architecture is the least expensive investment that you could make in from a cybersecurity perspective with the most impact. And I would reference there's a SANS white paper on this that describes it very well. Shift left for cybersecurity, I think, shifting left for cybersecurity. And I agree with that. I operate off that principle, so from an investment strategy perspective, understanding what's there, inventorying your architectures, understanding how you can protect the workloads and the processes and the business operations that are happening within your organization is key to really trying to build out what the path forward looks like, and understanding and building the governance around that to support that business model, not just implementing discrete technologies or processes to protect specific things.
Exactly. Good addition, Mike. Thank you. We do have some questions from the audience, and I would like to jump to that, if that is okay with everybody else. So Nivas, thank you very much for a very, very good session and a lot of information. For me, there's a lot to think about, so I'm definitely going to come back to you on those topics. I'm going to click on the Answer Live button, and I hope everything goes well. We have a question from Tim for Mike. We're going to answer that now if it's possible. Mike, you outline IEC 62443 merged with legacy ISO 27001. In 62443, at the component and systems level, certificate-based authentication is a key control requirement. What are you seeing with asset owners, implementation and management of this new requirement? What are key challenges for them? Is the question clear, Mike? Do you want to take a go at this?
It is. I'll take a go at it. Thanks, Tim, for the question. So I wouldn't say that 62443 is merged with legacy 27001. They're actually complementary to each other, and the 27002 control sets are fundamental or foundational for the 62443 standards, but applied differently in the industrial automation control space. And your question around the pivotal part of key management within the system is something that we see and we look at all the time. I think as asset owners, the challenge is how do you manage those certificates? Because as vendors, we're putting the capabilities for implementing TLS or secure communications and device certificates in varying ranges through whatever system we are. And as 62443 describes, security level 1 and security level 2, 3, and 4. I believe certificate management is at security level 2. So making sure that that capability is there within the construct of the system, and that asset owners can help manage those, whether it's with their own certificate management system or I see a lot of them doing self-signed certificates. There are varying degrees of effectiveness with that, but there's I think the key challenge here, and maybe I'm hopefully answering your question, is to really be able to manage those certificates, because if a certificate expires, then you could have dire consequences or lose communications and different. You have to be able to test those and make sure it fits within the construct of the security zone and communications or trusted system that you're building.
Thanks, Mike. And Tim, I hope your very good question is answered in detail. Mike, as always, you put a lot of details around it to make sure that we all understand the full picture. Thank you for that. We have another question from Nicole, and this is a question I was already expecting, but on the other hand, a little bit hoping that it would not be asked today. Will or does blockchain answer some of the questions around security or authentication with IoT devices and data storage? I'm going to pass on this one, so please, guys, if you want to answer this, take it.
Well, my personal take on blockchaining is that while it's an interesting concept, essentially it boils down to a cryptographic linked list, and there's a lot of crypto aspects to it. So I think it's still a young technology when it comes to industrial IoT and IoT. But there is a use case for blockchains, but it will probably be upstream rather than downstream. You could put compute platforms with enough horsepower for cryptographic use, where they could participate in a permissioned blockchain based on the industry sector. But I still personally believe it's a long way to go. It's an interesting concept, but in IIoT and IoT world, it's not easy to adopt that at this moment.
I agree with Srinivas's comments on that, and we're keeping a watchful eye on it, and have done some experimentation with it. But as far as it being a roadmap, I think it's pretty far out. I could be proven wrong, but it still needs to mature a bit as a technology in order to be as useful as we would hope within the operational technology space or the industrial space.
I agree with that, Mike, because especially in the OT field, we are not known for adopting new things very, very fast, right? We want to first of all make sure that it's secure, that safety is taken care of, that the process doesn't stop because a bit went in the wrong direction. So we are not the fast adopters, and blockchain for many people is still not mature enough. Another aspect which I personally see, and I spend a lot of time for clients in factories, most of those devices we are now speaking about simply do not have adequate computing power to be able to be an active participant in blockchain. Now, being a passive participant in blockchain basically means you are accepting a blockchain-enabled stream of information from another platform. And that doesn't really bring any kind of benefits at the moment, might change in the future. So from my perspective, and especially when we look at brownfield, and I keep mentioning that today, I'm aware of that, but especially when we look at the brownfield, blockchain is not a realistic technology to adopt for now. Let me see if we have another interesting question. Mike Nager asked us, how does an organization clearly delegate the responsibility for security between IT and OT teams? Who is responsible for ensuring that OT networks are properly segmented, for example? I love this question.
I'll take a run at it. I talked about the OT, IT, collaboration and convergence. I think it's really important, and this comes into the governance, and I mentioned building the governance around this and building the right teams with the right skill sets. I've seen customers do where they have a mixture of OT and IT, and they pull them into one team and they work on things, specifically focused on this, and defining those responsibilities within that construct, within a matrix. I think, at a minimum, bringing the two functions together and ironing it out within your organization, because each organization will be different. And I think, Srinivas mentioned that, and part of the complementary strengths of IT, they're going to bring in the forensic analysis, they're going to bring in the monitoring, the 24/7 incident response, having cybersecurity professionals at the ready when they're needed to help enable the operations, not get mired down into those specific things, but really be able to focus on the availability of the operations and ensuring that we have uptime and safety and reliability in those operations. So in short, I think it's up to each individual organization, but you have to put that matrix together, and you really need to go through the exercise of assigning those responsibilities. And it's not necessarily going to be easy. It's going to be something new. But I think coming out of that process, you'll have a new, each organizational function will have a better understanding of what the other one does.
Yeah, and the OT-IT coupling can be tight coupling or loose coupling. If you're following a Purdue model, for example, there's likelihood of more tight coupling between IT and OT, whereas there might be other systems where you want loose coupling. Because at the end of the day, IT's mindset is network operations centric, network centric, and they don't like to deal with heterogeneous OT devices. Whereas in the OT world, it's the other way around. They're less oriented towards networking and more oriented towards device. So the focus is different. And so depending on how the use cases for tight coupling versus loose coupling. In a nuclear plant, in an energy industry, they might go for tight coupling simply because they say what we have is what we have, which is the IT expertise, the forensic expertise. And they may start with that, and then they have to bring in field intelligence, the operators, and then maybe in a decade or longer, there will be a convergence of mindset
And I would just add that, part of OT network does look like IT, networks in a sense. And so there may be some overlap that can be reconciled that way, but there's definitely a need for some specialization in what the considerations are if you start to get lower level into, the stack, if you will, around those PLCs and the controllers and what the implications are at that level is in fact where there is a difference. And yet, if you kind of go up a couple layers with gateways and with sensors, just as an abstracted kind of level removed, they start to look more like IT networks. But I think reconciling the standards and thinking about the unique considerations, if you put things in those three layers, would be also helpful.
I think, to kind of build on that as well, the differences between when you take one skill set and apply it to the other, and I would say add some caution here to in a forensic response. If IT is running with forensic response or incident response and those types of things, one of the first things you have to do is contain, right, and understand what's happening within the environment. OT environments, to your point, Joe, with industrial protocols, time-sensitive networks, those types of things, you can't just take IT tools and put them into the OT environment and run scans or, see what's happening there. And oftentimes, quite often, especially in brownfield, you're not going to have the forensic capabilities within that operational technology environment or within that environment that are going to yield the results. It's and that's kind of that process you need to understand and really work with the capabilities of your particular organization. Is it IT, or do you bring in a services or a partner or somebody that you do incident response, or how do you assess this, and how do you build your operations plan and incident response plan around those types of things to ensure that you're leveraging those skill sets and capabilities of each part of the organization, but also not setting expectations unless you have a learning path forward that they automatically understand what's happening there.
Thanks, everyone. That was a really interesting conversation and explanation. I think we are approaching the end. I already see I see Greg's mouse moving nervous around the screen. So I think that's a signal that we reached the end. I have one question, and we are all educators of sorts and try to share as much and help people understanding. We have a question from Ratnamani, who writes, I'm a master's student planning to do my thesis on IIoT security threats. Where should I start? Well, first of all, welcome to our team, because this is exactly what we are looking for, people who are really interested in starting into this field. What can we suggest to this person?
I would say think like a hacker. Right? If you think like a hacker, you will see where the exposures are. And then you can help us fix that problem.
And I would add, I like the idea of thinking like a hacker, because you've got to think outside the box and think about things. But I also think thinking about compliance and starting there and getting a framework in mind and what some of the operational considerations are is every bit as important. So I think like a hacker 100%. And I also think like an operator, and how am I going to deliver these things in an operational setting that ensures safety as well. And so I think if you look at compliance, that gives you in part a framework, and that's one of the great benefits. It helps you get a common language, helps you to think about things. And so there are a couple good references Mike and Srinivas had around how they think about compliance, and I think those things are helpful. Now, I'll caution that compliance is not necessarily secure. Security is always compliant. However, I do think it gives you a universal language to think about, and then you can start to dive into topics from there.
I agree with both of those responses, and I would add, so thinking like a hacker and understanding the governance and the compliance around it, the requirements for that around it, but also as a thesis, as an example, I would think, okay, what are the implications for the risks in IoT, right? Taking it from not from just today, but looking 5 years down the road in a hyper-connected world, and all of the business interactions and decisions that are being made with new data with new efficiencies and edge computing, cloud computing, and the availability of all of that data, working toward more of a global and industrial perspective, not just focusing in on particular threats, but also thinking about it in the way of impact to operations, impact to industries and civilization, if you will, moving forward.
Yeah, and with the 5G force coming, you could probably get lost in that topic alone, but I think it's maybe just, kind of a background topic to overlay what Michael suggested.
I think this is wonderful advice to somebody who is willing to invest a lot of time to join us, to be a member of our team. We don't have enough members, so welcome. The advice that I would give is learn to break things for the purpose of improving them. And that is a very odd way of hacking, because a lot of hackers do it for other reasons. But when you learn to break things with the purpose to improve them, that's when you really start contributing. And we need more people than you, like you. Thank you so much for this question. And thank you for also sticking around with us. And if there's anything that I can do to support you with your thesis or further studies, please don't hesitate to reach out. And I'm pretty sure my colleagues also will be willing to pitch in. I think we reached the end of our very, very interesting session. I want to thank our guest today, Srinivas, Joe, Mike. Wonderful information. I loved the conversation. For me, it's always an enormous pleasure that when I have the honor to moderate a panel and learn something at the same time. That was really, really great. I also want to thank all our viewers. I see that we have somewhere between 60 and 70 up and down. So that means that we are not as boring as I sometimes think that we are with our security themes and our standards. It was fantastic. I want to thank everyone, but especially our guests and speakers for the contributions. And finally, Run Safe Security, thank you for making this happen. And IIoT World, it's a full day with great topics. Thank you for everything. Greg, you have the floor unless anybody else wants to say something.
Well, I learned something from Srinivas at Mokana and Mike from Emerson, so I'm grateful as well. So thank you, and it was a pleasure to participate today.
Same here. Thank you very much.
Thanks, everyone.